let's take a look inside this power supply. It's a Phoenix Contact Quint power. It's rated wide input range, which means it's going to be interesting. It's probably got a PFC boost converter in it, and output 24 volts 10 amps, which is quite good. It also has a boost mode. If you look at the specifications here, boost means it can go to 15 amps continuously or 60 amps for 12 milliseconds, which you use for clearing circuit protection so that the rest of the load that's not faulted can stay working. So I got these out of the trash, well, the scrap bin. There's probably nothing wrong with them. Thought it would be interesting to take a look inside them so we can see what chips and things have they used in there. Should be good quality power supplies with screws that are done up tighter than this screwdriver allows, because it's a cheap little thing. Got another one of those sets of stuff for cheap on AliExpress. It seems pretty good. So these supplies, the terminals, the pluggable terminal blocks. Oh yeah, we should look at that. So it's one piece of metal with an interesting fold in there to create some extra creepage between those suppression capacitors and the low voltage side. They've done an inside fold in there. Interesting. It's probably an expensive part to make that. The amount of folding and nice punching on there, which is all nicely deburred, is good. They've made use of the keying of these Phoenix contact connectors, which is something you don't see very often. You can put little plastic bits into those slots there and then put other things around those bits, and it means that these are now keyed so that one can only go into there, can't fit into there because it was blocked by those red things. Quite neat. That one there for the line input is a high creepage type, so with the little beginning of the sleeve in there and the sleeves around that, it creates quite a large creepage path between the contacts, which is good. The plastic goes into that hole before the pin. Yeah, good 5 voltages. So I think they've put screws under this label, which is a bit sad. Let's just peel it off. I don't know if we'll be putting this back together. I've got 2 others if I need a power supply. Presumably it works. So that's one continuous piece of metal, and there's devices on the back there, FETs and diodes and things, which are attached by a clip, a spring clip, which presses into that extrusion slot, and then it's a heatsink, and that looks like it's screwed onto the back there. So I guess once we undo all those screws, there's soldered in threaded standoff thingies soldered into the board on both sides, and there's also that. I think that will be the grounding to the case there. We might have to get a better screwdriver to start these. This thing, I should get some leverage. Yeah, there's a lot of screws in this. Are they all the same? Probably be thermal paste there. Yeah, there's a little bit around the screw, so I have to be careful before I get my fingers all through it. Okay, I've undone all the screws. Oh, it's already coming out. Okay. Bit of paste in the back there, not a crazy amount. Quite good insulation. And there's insulation between the board and the casing. And then there's thermal interfacing between some, I think, is that, I don't know, surface mount thingamabobs? Yeah. That's really interesting. So they've glued on, presumably with a thermal adhesive, some aluminium pieces on, and on the other side of that is some switching device, or maybe it's the diodes. And then the transformer is also heatsunk to the case with thermal interface there. And on the bottom as well. So they must be pushing it pretty hard. And then it's a glued on aluminium slug thing. So one thing I was wondering, when I was looking at this before, there's 3 wires going between the 2 sides. Is that the only thing going between the 2 sides? That would be a standalone input boosting rectifier? Possibly, because this front board where the mains input comes in is not attached to that side. And yeah, it looks like it. But there's something holding it. Okay, it's not holding it now. Yeah. Was there a connector in there, or was it just some glue? I think it was that there, glued onto that. So it looks like that might be a standalone input rectified power supply thingy, unless one of those is a control wire. That's interesting. There might be another low voltage power supply there. Or is that a CT? It says T on it. Let's look up some chips, find out what's going on. Let's have a look at some of the chips on this. So this input side here is a power factor correcting boost converter, and it's dual interleaved design since it's got 2 chokes there, and it'll have 2 FETs at least. Looks like there's 3 there. Maybe there's something else going on as well. There's some current sensing resistors, shunts. It's got the main chip there, UCC28061. Let's have a look at that. So it's a natural interleaving transition mode PFC controller with improved audible noise immunity. That's good. Typical application there. You can see the rectifier, which is on this heatsink here. There's some input filtering. Then there's a full bridge rectifier there. And then it goes through inductors, then FETs, diodes, and then the output capacitor, which here, I guess those are 2 in parallel. Nice Nichicon capacitors, 120 microfarads, 450 volts. So that's probably the smoothing capacitor after the rectifier. Big one, film capacitor. You don't want that too big, otherwise you'll erode the good power factor. It looks like there's a pre-charging circuit with a relay there. Yeah, it'll be that thing there. Some inrush current limiter NTC thing that then gets bypassed by that relay once the thing starts. The switching. There's inductors, probably got an auxiliary winding like what they show here. Well, they must do. That 0 current detection, so it can tell what's going on. So what will happen is the current will be flowing through the inductor, through the FET, back to ground, which is through there, through a current sensing resistor. And then when that turns off, current will continue flowing through there, through the diode to here, and it will boost by the voltage developed across the inductor due to the magnetic field in it, in series with the voltage coming from the line, and that allows it to boost. And that's monitored. There's 2 voltage sensors there. The regular V sense for regulating, and then there's an HV sense. I guess that's some sort of shutdown thing if it gets too high for some reason. That's what's going on inside it. Voltage sense comparator, controlling that stuff there. And there'll be various detections, or VNAC is it? So it can track what's going on. It monitors the incoming waveform, the AC waveform, that thing there, VNAC, so it can see as the sine wave of the voltage goes down, it will reduce the on time so the amount of current flowing follows the voltage. That's from that thing there. And then the current sense is a comparator, and that has an overcurrent detection, which will go into something somewhere on here. OC. Oh, into there, into stop. Oh, so it looks like it has a single phase mode. If you do something, then it will be running just one of the outputs. There's a more detailed design. Great, so that makes a voltage probably around 400 and something, but less than 450 because of the voltage of the capacitors. Having it two inductors, two FETs, which means they're interleaved when one's on, the other's off, it means you can get more power through smaller components, and the amount of ripple you end up with is less because there's current flowing more of the time, so these capacitors don't need to be as large as what you'd need if you just had one phase non-interleaved design. So that makes DC voltage, which comes across here, these wires, and there's a thing there which might be another little power supply. I think that's what that is, like an auxiliary power supply. And there's a microcontroller under there, a little ST microcontroller. Then the main controller for the operation of this, it looks like this thing here, which is UC2843, which is that this? Yeah, U2843. So there's a whole range of devices in this series. Is this the right thing? That's what it says, 2843AD. Oh yeah, there's different packages, it's just they showed that with less pins. 281828. And there'll be a table there somewhere that tells you what all the different things are. 284, 2843. So there's different undervoltage lockouts. So this one that we have, the 3 on the end indicates it's that temperature range, which is the 2, and then it's that turn on level, which is the 3. Whereas if it's 2, then it's for higher voltage stuff, which normally the higher voltage is good because it means you can ensure a good gate drive for a FET. But in this application, they're not using that because there's a separate gate drive. Well, there's separate gate drives on this side, which I think are for synchronous rectification, and I think there might be a gate drive transformer, possibly. Am I just making up stuff? I need to study this circuit for a long time to work out what's going on. So what's that thing in there? An S11682 by International Rectifier. Yeah, look, there you go, S11682. So that is the right thing. Yeah, so this looks like a resonant converter, the main converter, because it's got another inductor here, and there's some capacitors in there, and then there's the main transformer. And then it's got this little pulse transformer thing, and there's some gate drive ICs there, and then there's these FETs. And in between them, there is this thing we can see on the screen, IR11682, secondary side high-speed controller for synchronous rectification in resonant half-bridge topologies. So I think that's what's going on there, that little chip there will be detecting the switching pulses through this transformer and then driving these FETs to do the rectification better than what a diode could. This will be fast. And then those have got heat sinks. There'll be lots of wires under the pad there, and then that couples the heat through to the other side where it was touching the case. And I guess that little microcontroller that's in there is looking at the load current and then deciding if it needs to step on the gas to blow fuses with that boost mode. And you can see down between those capacitors there, there's a little bit of copper showing, and that is a current shunt. Can't tell what it says. It says 0002 maybe that's 2 milliohm shunt in there, and that's probably being monitored. There's some other things around here that looks like op amps, so they might gain that up a bit, and then that microcontroller is probably monitoring the voltages, or monitoring the current and the voltage output, so it can put it into high gear when it's time to generate some current, some more current. There's 2 optocouplers there going that way, So they'll be putting doing the feedback back to the switch mode controller there. And there's one there which makes me think that's another little switch mode controller, which must be that chip. There's 258 on it, I think. Possibly an op amp, but that doesn't make sense because there must be a switching controller somewhere. Well, unless it's that thing, but that's probably the fit for it. Maybe it's a discrete controller thing. Or the controller for it's over this side, because that wire there, the red one, seems to go straight down to that transformer. A bit weird. Oh no, that also goes over to there. So, it might be a self-resonant thing, or it's working on the switching frequency generated by that main controller thing, and then gating that with the feedback through the optocoupler. One of those little SOT23 things is probably a TL431 as a reference. There's also some other very tiny 5-pin thingies in there. I don't know what that is. More logical gate drives maybe? Anyway, there you go. That's a look at Phoenix Quint Power 24 volt 10 amp power supply. But wait, there's more. From the magic of buying lots of them, I didn't buy any of them, but by the magic of owning lots of them, got here a bigger version. So have a little look at that. So it's just something I've had hanging around for a few years in bits. So that's another Quint Power Phoenix, but this time 24 volts 20 amps, so it's twice the power. Quite grunty. And it's already been taken apart, except, oh yeah, look at that. So that one boosts to 26 amps, 120 amps for 12 milliseconds. So it's double, isn't it? The other one was 60 amps for 12 milliseconds. Oh, maybe we should have looked at this one to start with, because maybe we can read the stuff easier. It's probably all the same things in it. Probably just the same thing, but scaled up. Although it's not the same, because instead of using a off-the-shelf PFC controller, this one has a lattice FPGA or CPLD thing there, which does still a dual interleaved PFC booster. And then what's really surprising about this one is the connection from this side, which the input side here, the power comes in the terminals there through a filter fuse, and then it comes out these screw terminal things onto there, more filtering, soft charging relay, the NTC, input capacitance, rectifier, and then into the boost converter with the FETs and inductors there. Then all the power goes through just this generic little pin header thing. You can see it, the track there comes up one via, and it goes onto 2 pins of that, and then the other track, which comes up in an internal layer, goes onto what is possibly just the end one, and then that goes into there, and that brings all the power over, which is quite surprising that to do it on just a pin header thing. And yeah, that goes into there. There's a fuse there. I guess part of it's fused because there's a top switch, like offline switch mode controller thing there, which I guess drives that to provide the auxiliary power, and then the main circuit through here, which I think it's a resonant converter again with resonant inductor there, the capacitors, and then this main isolating transformer, which has got quite severe Litz winding on it, and those come out, and then they're soldered into the board separately at the various locations. And then there's a whole bunch of ceramic capacitors, and then that eventually goes over to these. So it must be a very high frequency if they can get away with a row of ceramic capacitors there. Looks like that's the shunt for measuring the current, and similar synchronous rectification. For some reason I didn't peel the back off. I think those are on the boost converter side. Those must be current sensing resistors. Yeah, it says Dale 0.05 ohms. Be good quality current shunts. Alright, there's a rough look at 2 different Quint Power Phoenix power supplies. So the reason why I was interested in looking at both of these input stages with the PFC booster is because I'm or I'm supposed to be designing a new version of this photo flash that I made some years ago. Is this one, it's just a voltage doubling rectifier, so it takes the from around 110 to 120-ish input, and then voltage doubles that up to 300 and something to power the flash, which means you can only run it on that 120 volt supply. So I was thinking, make a new one that uses an active PSC booster, but reconfigure it to run as a buck boost, 2-switch buck boost, so it's not inverting maybe. And that way it can run off a wide input supply range and it can regulate the output voltage. And by using a buck boost, very important, it means there's no free path through the rectifier to charge the capacitors in an uncontrolled way. It will be a regulated charge. But otherwise you're just going to blow up the flash capacitor, especially if it's a big one, when you plug it in and you get a massive inrush or trip breakers. But by putting a buck boost converter in the way, you'll be able to control the charge. That's the plan. Make a better, bigger version of this compact photo flash with active PFC input to allow a wide input voltage range, and also use a IGBT to control the flash on time. So yeah, that's something we'll have in eventually, maybe once we get through the VCRs perhaps.